Hello and welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 141, linked list cycle. So for this problem, you're given the head of a linked list and you need to determine if the linked list has a cycle in it. So for this example, we have a linked list where 3 is pointing to 2, 2 is pointing to 0, 0 is pointing to -4, and then -4 is pointing all the way back to 2. So this is a cycle. This has a cycle in it because there's one pointer that's pointing back to another back to another node in the list. But if we had a linked list where it was 1 pointing to 2, 2 points to 3, and 3 points to none, well then this we're going to return false because there's no cycle in this linked list. But if we took this this 3 and instead of pointing it to none, pointed it back at 1, well then it would be true that there is a cycle. So we need to determine if the linked list has a cycle in it or not. So how can we determine this? Well, there are a couple of approaches. The first, most intuitive approach would be to use a dictionary or a hash map. If we had a dictionary, then we could put each node into the dictionary, and then we could look in the dictionary and see if the node was already in there. So when we traverse this, when we go to this node, we can see if it's already in the dictionary. It's not in the dictionary, so we're going to put it in the dictionary. Then we're going to go to the next node. Is this node in the dictionary? No, it's not in the dictionary, so we're going to put it in the dictionary. And we're going to go to the next node. Is this node in the dictionary? No, it's not in the dictionary, so we're going to put it in the dictionary. Then this node, not in the dictionary, so we're going to put it in the dictionary. Then this next node takes us back to this node. Well, this node is already in the dictionary, so we're going to return true because we have found a node that's already in the dictionary. Otherwise, if we hadn't have gone back to that node, it would have taken us to false, it would have taken us to none, and we would have stopped traversing the list, and we would have never found a node in the dictionary already that we had gone to, so we would return false. So that's how you could use a dictionary to solve this problem. But if you use a dictionary, then that's extra space. It's going to be an O of n time, but also O of n space, because you're going to need to make a dictionary, and you're going to have as many elements in the dictionary as there are nodes. So that's going to be O of n space. So the question is, can we do better than this? And we actually can. We can actually find a solution that is O of n time and O of 1 space. And the way we can actually do this is you have to know a particular algorithm called Floyd's algorithm. Floyd's algorithm. So You probably wouldn't be able to come up with this solution on your own, but if you know the algorithm, then it's pretty simple. So essentially, Floyd's algorithm proves that if you have 2 pointers and you have a slow pointer and you have a fast pointer, and your slow pointer moves one space, and your fast pointer moves 2 spaces, and if there is a cycle, then the 2 pointers will meet. And why is that true? Well, if you think about it, say you had a track, and this track was a circle. This is not a very good circle. Let me try to draw a better circle. So you say you had a track. The track was a circle. And you had a slow person on the track and a fast person on the track. And the fast one person was going 2 times as fast as the slow person. Well, if they both started at the same place, or even if the fast one was ahead, they would eventually, if the fast person went around the track and the slow person went around the track, the fast person would eventually catch up to the slow person and lap the slow person. If they're on a circle. So they would again meet. So that's basically, and there's, Floyd, he proved this algorithm with a proof, and there's all sorts of math to back it up. But basically you have to know this algorithm where you have 2 pointers, the slow moves 1 space, the fast moves 2 spaces. And it actually works if you have the slow and fast start at the same space, or if you have the fast pointer start 1 space ahead. It'll still work regardless of whether you do that, but it just makes it a little bit simpler for the code if you start the fast pointer 1 ahead, because then you want to see if they meet, and if they meet if you start them in the same place at the beginning, then it will never enter the loop because it's already meeting. So, but it always works where the fast person will always catch up to the slow person in a certain number of loops through, if there's a cycle. But if there's no cycle, then the fast pointer is going to get to the end of the list and there's going to be nowhere to go. So then the slow pointer has not caught up, so it is no cycle. So that is the algorithm, and let's just see it coded up. So the first thing we have to do is take care of an edge case, and the edge case is if there is no list at all, then there's no cycle. And we can't do the algorithm if there's no list, so we have to take care of this edge case. So if not head, then return false. There's no cycle if there's no list. Okay, so now we know that there is at least 1 node in the list. So we're going to start our slow pointer off at head, and we're going to start our fast pointer off at head.next. Now, if there's only one node in the list, then head.next is going to be none, and that's fine. So we're going to start off at slow is head and fast is head.next. Now we're going to run our while loop, and we're going to run while we have a fast pointer. So if there's no if there's only one thing in the list, this is immediately going to break out of the while loop. So while there is a fast pointer and there's a fast dot next, so we're not at the end of the list. So it's going to break out when we get to the end of the list, when there's nothing to go to next. And also if they're not meeting. So slow does not equal fast. So it's going to stop either if slow and fast are the same, or if there's nowhere else for fast to go to. So while we're in the loop, we're going to make slow increment by 1. So slow is going to equal slow.next. So, and fast is going to go 2 spaces to the right. So fast is going to be fast.next. And okay, so now we're out of our loop. So now either there's nowhere else for fast to go to, or slow is equal to fast. So if slow is equal to fast at this point, then we know that there is a cycle. So return true. And otherwise, this is if we ran out of places for fast to go to, and so fast is at the end of the list and slow has not caught up. So that means there's no cycle. So we're going to return false. And that's the code. And let's run it and see what we get. So we're getting the correct answer. There is a cycle. And let's submit. And yes, so this successfully passed submission. And like I said, this is going to be O of 1 spaced complexity. We're just using a few pointers. And this is going to be O of n time, because it's going to have to traverse the list at least once, possibly more times, but it's eventually going to stop. So it's going to be some number times n, which is a constant. So we're going to drop the constants for the time complexity. So we're going to get O of n time and O of 1 space. So I hope that was helpful. Thanks for watching, and I'll see you in the next video.